So hey everyone, welcome back to the channel. I am Navarun, and in the previous video we learned about the Node.js Crypto Module. Then we learned how to generate secure random values using the random bytes, how to generate like unique IDs using a random UID, and how hashing works using this create hash function with the help of SHA-256. But there was one very important thing that I mentioned, that is, we should not use a plain SHA-256 for storing user passwords in a production level application. So in today's video we are going to understand what we should use instead, and that is where this script comes in. By the end of this video, you will understand how to securely hash a password, then how to generate a salt, and how the salt works. And finally, we can verify a password during login. So let's get started. Now the question is why we cannot store passwords directly into our databases. Let's imagine we are building a backend application and a user creates an account, okay, and then chooses a password. For example, the password maybe look like this: password 123 or admin 123. Okay, so a beginner might simply save this password directly into the database, but this is extremely dangerous. If our database is compromised, then the attacker, can immediately see the actual passwords, and that is the another problem. So many users reuse the same password across multiple websites. So if a password is exposed from one application, it could potentially be used to access other accounts as well. So that is why we should never store passwords and as plain text. Instead, we need to transform the password before storing it, and this is where password hashing comes into this picture. Now, in the previous video, we used this create hash function with SHA-256. For example, we import this create hash function from this crypto, and we use it over here. And this actually works perfectly for demonstrating how cryptographic hashing works. But we should not use this plain SHA-256 algorithm for password storage. Why? Because SHA-256 actually it is designed to be extremely fast, but that I know that sounds like a good thing, right? Actually not. But when we are storing passwords into our database, imagine uh, an attacker has obtained a database containing password hashes. So they can use powerful hardware to try huge numbers of possible passwords. If the hashing algorithm is very fast, then the attacker can test a massive number of password guesses very quickly. For this password storage like scenario, we actually want the operation to be intentionally expensive. That is why we use the password hashing algorithms such as like this Scrypt, Bcrypt, and Argon 2 ID. Okay, so these algorithms are designed specifically for the password protection and make large scale brute force attacks more expensive. For our Node.js course, we are going to use this script because Node.js already provides it through the built-in crypto module. That means we don't need to install any kind of another package just to use it. Now, what is this script? So a script is a password-based derivation function. It is actually designed to make password guessing more expensive by requiring both computational work and memory. So and because Node.js provides a script through the built-in crypto module, we can use this directly into our application. Let's see how it works. So over here, I will create a new file called day6.ts, and also I will change the name from here also, day 5 to day 6. Okay, then I will first import something. The first one is the randomBytes, and then is the script. Okay, so I will say import something, uh, let's say randomBytes. then is script. Okay, and I will call this script as script. Let's say callbacks or the callback. Okay. Now we are going to use this randomBytes function because we need something called a salt. Let's understand what a salt is. So what is this a term, a keyword, salt? So actually, a salt is a random value that we can generate for each password before performing the password hashing operation. Let's imagine uh, two users have exactly the same password. Okay, so the both users use this password, user A and user B. Over here, you can see this. So if we process both passwords without a salt, we would get the same resulting value. That's not a good idea. Okay, so instead we generate a different random salt for each password. For the first user, we might generate one random salt, and for the second user, we generate another random salt. Even though their passwords are identical, so the resulting password hashes will be different. That's one of the main purposes of using a salt. So the salt does not need to be secret, so we can safely store it alongside the password hash, but we should generate a unique random salt for each and every password. Now let's generate a salt using this randomBytes function. Let me switch back to my VS Code, and over here I will say const salt. Okay, then I will use this function randomBytes of let's say 16. Okay, then I will convert it into hexadecimal string. So I will say dot to string, and I will pass this hex. Okay, then I will log this salt. Oops. Okay, and I will open it in terminate integrated terminal. Then I will simply run this. Okay, so we might get something like this over here. So if we run the application again, okay, uh, we will get a completely different value. You can see this. So that is exactly what we want. We are generating 16 random bytes and converting them into a hexadecimal string with the help of this dot to string of hex. Okay, so now let's use this salt with the script. So the traditional Node.js Scrypt API uses a callback. But since we are building our backend using modern TypeScript, we want to work with async and await. So we are going to convert the callback based function into a promise. For that, we can use Node.js a built-in promisify function. Import it like this. So over here, I will import, oops, import promisify, okay, from util. Okay, now we can create a promise based version of a script. So I will first comment out this line, then I will say const let's say script. Okay, then I will say promisify. Okay, then I will uh, use this script callback over here, and then we can use the await script function inside our asynchronous functions. Okay, so let's create our password hashing function first. I will say async function. Okay, async function. I will named it as this hash password. Okay, over here I will pass this password, then I will receive it as a string value. Okay, then I will say const salt and equals random bytes. I will use it again. Okay, then I will convert it into a hexadecimal decimal string. I will use the hex. Okay, then I will initialize another variable. I will name it as let's say derive. Okay, derive key. Then I will say await a script. Okay, then I will pass three things. The first one is the password, then is this salt actually. Okay, salt, and I think the size. Okay, buffer size, that is the 64, and I will say as buffer. Okay, now I will return this. Return, I will use the backticks append, then I will pass this salt. Okay, then I will use this append again. I will pass this derived key, then I will not I have to convert it into the hexadecimal string, and I will pass. Okay, let's understand this code again. First we actually receiving this password as a string over here. Okay, then we are generating a random salt. Okay, this line line number 11. After that we are passing the password and the salt and the desired key length into this script, and here we are using the 64 bytes as the derived key length. Okay, and finally we are returning the salt and the derived key together separated by a colon. Okay, for example, the final value might look like this. Let me first uh, call this password. Okay, over here, not like this. So first of all I have to say const password hash. Okay, then I will use the await, and I will use this hash password. Then I will pass this password. Let's say it is password 1234. Okay, okay, the current file is a common JSON top level. Okay, okay, over here, first thing first, I will log this password hash. Okay, okay, I have to first change this common JS. I will use this as module. Okay, then I will uh, run this again. Okay, I will start the development, run the development. Okay, okay, you can see this over here. So this is actually what we need. We will get something, also you will get something similar to this. Now let's call this same function again with exactly the same password. First thing first, I will say console.log. Let's say not like this. I will change the name password hash to hash1. Then I will copy this line again. I will paste this and I will change the name. to password hash 2. Okay, and I will use the exactly the same password. Then I will log these values. First is this password hash 1, and I will use this 2. Okay. Okay, let me write something over here. Hashed password underscore 1, and I will use this, and it will be 2. Okay. Okay. So you will notice that the two values are different. At first, this might look strange. We used the exactly same passwords. So why are the results different? The reason is the salt. Every time we call this hash password, okay, this function, we are generating a new random salt. Because the salt is different, the resulting derived key is also different. So this is exactly what we want. Now let's think about what happens when the user logs in. So during the registration, we stored the salt and derived key in the database. Okay. Later the user enters their password again. For example, let's say the password 123. We don't decrypt the stored password hash. There is nothing to actually decrypt. Instead, we take the password provided during the login time and retrieve the stored salt from the database and run the script function again using that password and the stored salt. If the newly generated derived key matches the stored derived key, the password is correct. If they don't match, the password is incorrect. So let's implement that also. Now we will create a function called let's say verify password. Okay, over here, let me first uncomment these lines. Let me okay, I will say async function. Okay, uh, verify password. Okay, over here I will pass uh, uh, first is the password. I will receive it as a string. Then I will take the stored password. Okay. Okay, I will also take this as a string. Now I will create with an array with salt and stored salt, and I will say stored password, and I will use the split method just to use this column. Next I will say const let's say derived key. Okay, derived key, and I will say await a script, and I will pass the password, then the salt and the 64 as buffer I have to mention. Okay, then I will simply return this. Over here I will say return this derived key, and I will change it to convert it to an hexadecimal string. Okay, so I have to give a logic over here, a condition, that is it will be equals to the stored password. Then you can return this. Okay, so let's understand what is happening over here. So our stored password value look like this salt. Okay, and the hash password over like something like this. Okay, so we use this a const salt and stored salt, sorry, not salt, this will be this hash. Okay, and I'm using this colon with the help of this split method. Okay, so this actually separates the salt and the stored hash. Then we take the password entered during login and use the stored salt. Okay, so this line actually generated value with the stored hash, and then I return this line because if they match, the function will be return true. They don't match, it returns the false. Now let's put everything together into one complete example. So I will simply uh, comment out all of this. Okay, then over here, oops, I will import, let me write something, full example. Okay, I will first import. Okay, I will first import the random bytes and the script as uh, a script callback. Okay, then I will also import the promisify from the util. Then I will initialize a variable. Let me copy this line. This line. Okay. Okay, and I will also copy this function again, this hash password function. I will uncomment this. Okay, then I will also copy this verify password function. Okay, okay, then I will use a main function to log all of this data. Async function main. So this is the main function, and I will say const password. Let's say it is password 123, and this time I will use a symbol. Then I will initialize this stored password. I think it is stored password. Yes, it is stored password, and I will say uh, await this hash password, and I will pass this password. Okay, then I will log this stored password as the stored password, and if it is valid, then I will verify use the password 123 as the stored password. Otherwise I will call this as a correct password. Okay, so let me write all of this. First I will log this. Okay, and I will say this stored password. Okay, and I will use this stored password. Then I will say is valid. So I will use this await again. I will call this verify password function, and over here I will pass the password. Let's say it is password 123, and I will pass this stored password. Okay, I also this log this is this uh, uh, is valid variable, and I will say okay, correct password, correct password, oops, password, and I will pass this is valid. Again I will copy this line, I will simply paste it over here, and this time I will say invalid, and I will call this verify password, and if it is wrong password, okay, let's say if it is wrong, oops, wrong password, then I will log this. I will copy this line, I will change the name to invalid and incorrect password. Okay, or let's say wrong password. Okay, incorrect password. Okay, 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 and now I will call this main function. Oops. Cannot find the name main. Why asynchronous way? Async. Oops. Function. Okay. Okay. So if you run this application like this, so you should also get something similar to this. So we have actually successfully created a password hashing and verification flow. Now the question is, where would we use this? Imagine we are building a registration API. Okay, so the user uh, over here sends an email and password to our backend, and the backend receives the password. We call that is the hash password. Okay, of the password, something like this. Okay, something like this. Now the function actually generates the salt and derives a secure key. Then we store the resulting value in our database. Actually we never stored the original password. Later when the user logs in, our login API receives the password again, and we retrieve the stored password value from the database. Then we call this verify password. I think yes, this is verify password function. Okay, with this password and this stored password, if the result is true, we know the password actually, so that is correct. At that point our authentication system can continue and generate an access token, and if it is wrong, then it will show this false. Okay, okay, let me why it is we getting this false. Let me check this again. So it is actually, I think, the problem in between this hash password function. So actually the problem is occurring because of this space. Okay, so in this case, if we retrieve the stored password value from the database, then we call the verify password and the stored password. Okay, actually this stored hash is declared, but its value is never read. Because of this, I accidentally use this stored password. This is not stored password, this is actually the stored hash. Okay, now you can see this, it is true, and this is our stored password. Okay, so at this point our authentication system can continue and generate an access token. So we will build that complete flow later when we reach JWT authentication in this course. And there is one more thing I want to mention in this simple demonstration. We are comparing the generated hash and the stored hash using this derived key dot the toString of the hex that is I accidentally use the stored password over here. So this is actually very useful for understanding the concept. However, for security sensitive authentication code, a constant time comparison like such as Node.js timing, I think the safe equal function, yes it is, Node.js timing safe equal function should be considered instead of a normal string comparison. And we will discuss this in more detail when we build our production style authentication system. For now, the most important thing is that you understand the password hashing flow. So let's quickly understand what we have built. So during the registration, the user provides the password, then we generate a random salt, and we use the password and the salt with a script. Okay, from here. And we get a derived key. Then we store the salt and derived key into the database. Later, during login, the user provides the password again, and we retrieve the this stored salt over here. Okay, and we run this script again using the entered password and the stored salt. Then we compare the newly generated value with the stored value. If they match, the password is correct, and if they don't match, the login should fail. Most importantly, at no point do we need to store or retrieve the original plaintext password. And with that, we have completed our Node.js Crypto Module section. In previous videos, we started with the process object and learned how Node.js provides information about the running application and operating system. Then we learned about process.env and environment variables. Then we built a small CLI application using the process.argv. After that, we moved into the crypto module. We learned about this randomBytes, this random UID and create hash. And finally, we learned how to securely hash and verify passwords using the Scrypt. So these concepts will become extremely important later in this course when we build our authentication system with registration login, like the JWT access tokens, refresh tokens, and many more. And that's it for today's video. In the next video, we will move away from the process and crypto modules and start exploring the OS module and path module. We will understand how Node.js can interact with information about the operating system, and how we can work with the file and directory paths in a reliable way. So make sure you follow the playlist in order. Thank you for watching. I will see you in the next video. Till then, bye bye. Happy coding.